I'm certain every grade 7 learners knows what a circle looks like. You have seen circles. You have seen circular objects or you have seen circles in your daily life. So in this video, we want to discover the relationship between circumference and diameter. I know you have an idea what a circumference is or a diameter is, but let's have a recap of what a circle looks like and try to illustrate the relationship between circumference and diameter. Let's start by drawing a random. Circle just to illustrate what we are doing. This circle, let's place it here and let's use the white. White. I hope it's going to fit. Now let's draw 1 to make a circle, 1 to make a circle. This is what we call a circle. A circle is just a circular object or a circular shape. That's a circle. So from this circle, we want to know what's the circumference, we want to know what's the diameter, and we want to know what's the radius. Very simple. Circumference is the distance around a circular object or shape. Now this is a circular shape. This is a circle. So when we move around this circle, the distance that we're going to cover is what we call a circumference. Just for illustration, this is how you move around a circle. Maybe let's say you start from here and you move up to where you started. The distance that you have covered is called a circumference. So what's a circumference? A circumference is the distance around a circular object or shape. So circumference is distance around a circle. That's the circumference. Distance around a circle. Around is just a circle. You can write here the distance around a circle. That's the circumference. And now what's the diameter? What's the diameter? A diameter is the length of a straight line from one end of a circle to the other end. And the diameter passes through the center. So the diameter divides the circle into 2 equal halves. Let's illustrate that one. We can just draw a line that passes through the center and that passes through the center and touches one end of a circle and the other end. So here it can be any line as long as it's passing through the center. Any line that passes through the center. Or let's change the color. Which color here? Let's just use this one. So we are going to draw a straight line from one end of a circle to the other end, passing through the center. Not good at drawing, but this is the line. This is the line. That's the line. Let's make sure that the line is not passing. Now that's the line. You can see that this straight line is from one end of a circle. It is from one end of a circle to the other end, and it passes through the center. And this line divides the circle into 2 halves. you can see we have two equal halves. So that's the diameter. We can say that the diameter divides the circle into two equal halves. So diameter divides a circle into two equal halves. Two equal halves. Now what's a radius? What's a radius? A radius is the length of a line from the center of a circle to any point on its circumference. So it's the length of a line from the center of a circle to any point of its circumference. So in short, circumference is half the diameter of a circle. Half the diameter of a circle. We say that this is the diameter from one point to the other point passing through the center. Now, let's illustrate for the radius. Radius is just from the center to any point of the circumference. Any point, you can choose any point. Any point. Now that's my any point. So it's here. That way. So this is my radius. This is my radius. Let's say that this is my radius. Yeah, radius, and this is my diameter. And now going around the circle is a circumference. Going around the circle is a circumference. Yeah, circumference. Now that's all you need to know about the circles. At these points, that's all you need to know about the circle. With this, it will be easier for you to understand the relationship between circumference and diameter. Note that we have already learned what a circle is, how a circle looks like. We have learned about the diameter, we have learned about the circumference, we have learned about the radius. It's now time to discover the relationship between circumference and diameter. Now, what you are seeing here is a circle. This circle has a diameter of 2.1. The diameter is 2.1, and I have not wrapped a strip of paper, but there's a strip of paper wrapped around this circle. I want to unwrap that piece of paper, and the length of that piece of paper will represent our circumference because it's going around the circle. So we want to unwrap it, find the length. That length would be our circumference. If we learned that going around the circle is the circumference. So let's unwrap it. We are unwrapping the paper from that circle. We are unwrapping the paper. We have unwrapped the paper. So now unwrapping the paper has given us the circumference, and now our circumference is 6.6. Now to discover the relationship between circumference and diameter, we want to divide the circumference and the diameter. Let us use C for circumference and D for diameter. So number one, this is just our number one simulation. Circumference over diameter. Circumference over diameter for our number one simulation. Our number one simulation, our circumference is 6.6, and our diameter is 2.1. So what do you get when you divide 6.6 divided by 2.1? Use your calculator to divide that. Use your calculator. 6.6 divided by 2.1. I'm getting 3.14285. So many numbers there. So I want you to limit the answer to 3 significant figures. 3 significant figures, you'll get 3.142, 3.142. And you can also use your calculator. You can shift it and look for the fraction in the fraction form. For the fraction form, you're getting something like 22 over 7. So what does this tell us? It tells us that the diameter goes into the circumference 3 times, 3 full times. And now we have those points. Now let's illustrate this one. Our diameter is 2.1 and we want the diameter to go into the circumference. Now, what is the diameter going into the circumference? The circumference is that length of the length that's covered the circle. The length that went through the circle, that's the circumference. Now, you can watch. Let me rub that one to show it well. Use my hand. Now, that's the diameter. That's the diameter falling into the circumference. Now, that's the first one. And now that's the diameter making the second one. And the diameter third one. Now, as you can see, the diameter has gone into the strip of this paper 3 times, and there is a small space here. This small space here stands for the decimal that you are getting there. The decimal that you are getting here. What are this decimal? 1.42. This small, let me show it here. This small space here, I can show it to the blue. This small space here, is represented by 1.42. So the diameter goes into circumference 3 times, and it's leaves a small space which is represented by 0.142. I hope you're getting that. I hope you're getting that. Now we can also try with another diameter to see the relationship between the circumference and the diameter. Let's try another diameter. Now, let's start one. Let's move to 2.8. That's one of the famous diameters. 2.8. Yes. Now, our diameter is 2.8. Our diameter is 2.8. Want to unwrap the strip of paper to find its length. The length of the strip of paper. The strip of paper that goes around this circle. Its length is the same as the circumference. Now let's unwrap to find that length. That length is equal to the circumference. Let's unwrap. We are unwrapping to find the length of the strip of paper, and that length is equal to the circumference. Damn, we have a new circumference. We have with a new diameter, we have a new circumference, and now I want us to test if we are still going to find the same answer. Now, in this case, let's say the second simulation. Our circumference divided by our diameter equals, our new diameter is 2.8 or 2.8 divided by I'm not doing the right thing. It should be circumference over diameter. Circumference 8.8, and the diameter is 2.8. So divide your 8.8 by 2.8. What are we getting? 8.8 divided by 2.8. What are we getting? 3.14. 3.142, which is the same as 22 over 7. 22 over 7. Let's try the last one to see if the same relationship will hold. Let's try the last one. Now for the last one, let's have another diameter. Let me use 3.5. 3.5 is also for one of the popular diameters. Yes, 3.5. Now for 3.5, let's repeat the same simulation. Let's find the length of the strip of paper by unfolding it from the circle. The length of the strip of the paper will be the same as the circumference. Now, very fast with this one. Now for the dart simulation, we can see from our dot simulation, we have the circumference and divided by diameter. Our circumference this time is 11. Our diameter is 3.5. Now use your calculator to find the relationship. 11 divided by 3.5. 11 divided by 3.5 is 3.142. 3.142, which is the same as 22 over 7. 22 over 7. Now, what have we learned now? What have we learned? We've learned that for any diameter, if you divide the circumference by diameter, you'll find that the diameter goes into circumference 3 times, and it leaves a small space, which is now 0.142. Let's see this diameter 3.5 going into the strip of the length, which represents the circumference. Now let's see the diameter going into the strip of paper 1 time, 2 time, and that's the 3rd time, and we have a small space. This small space is the small space is our 0.142. So it goes there 3 times, and when you add the 3, you get 3.142, which is the same as 22 over 7. So here is our discovery. This is our discovery now. This is our discovery. What's our discovery? Whenever you divide a circumference and a diameter, you get a constant. Whenever you divide a circumference by a diameter, you get the same number. And this same number, which is 22 over 7 or 3.142, is called a constant. We are going to call it as constant. We can use black. So this 22 over 7, this same number here, 22 over 7, 22 over 7, 22 over 7, this same number is called a constant. So we are going to call it a constant. This number is called a constant. And in maths, we call it pi. In maths, we call this constant pi. You can write it here. Pi. Yeah, in maths, we call it pi. And the symbol of pi in maths is this way. You'll be writing pi this way. We say that mathematicians are lazy, so they can't write pi. They'll use a symbol. Yeah, this is a symbol for pi. This is the symbol that you'll be using to write pi. Now, going on with our discovery, let me use another color again now to show the relationship between circumference and the diameter. So to conclude, the relationship between circumference and diameter is that circumference for C, let C represent circumference as we have been doing. Circumference over diameter. When you divide the circumference and the diameter, what you get is 22 over 7, and 22 over 7 is a constant. And that constant in maths, we call it pi. And since maths we are lazy, we are going to use a symbol to represent that pi, and that pi is represented this way. This is how we represent the pi. Now, this is what we have learned. This is the relationship between circumference and the diameter. When you divide the circumference of any circle, no matter the size of the diameter, any circle, when you divide the circumference of any circle by the diameter, the answer will always be the same number, and that same number is called a constant, and this same number is 3.142. That same number is 22 over 7. That same number is what we call a pi. So here is 22 over 7. Now from this, how do you find the circumference of a circle? It's so easy. The circumference of a circle, if you want to find the circumference of a circle, you just isolate the C by dividing both sides by D. Then you will find the circumference of the circle. So this is how we find the circumference of a circle. When you're asked to find the circumference of a circle, you say C, which is circumference, C for circumference, we say C equals, you multiply D, both sides, multiply D both sides. Let me just show you here. You multiply here by D, and you multiply here by D. So this D will cancel this D, and you have that your circumference will be pi D. Your circumference will be pi D. You have here pi D, pi D, pi D. Pi D. So that's all we have. That is all we have for. That's all you have to understand. That's all we have. This is what we have. Just trying to color it. This is what you should know. That circumference equals pi D. Circumference equals pi D. So that's all. That's the relationship between circumference and diameter. Always know that circumference equals pi D. I know you know what the pi is. You know what the D is. You know what the C is.